Everybody. My name is Hans-Rudolf Hotz. I'm working at the Friedrich Miescher Institute in Basel, Switzerland, and it is my great honor and great pleasure to actually chair this webinar series on Galaxy Advanced Features. There are altogether 4 seminars spread over the month of March, where we try to cover newly added features to Galaxies, sometimes hidden features, or just sort of features which kind of got lost in this ever-changing world of Galaxy, where it's really getting one new feature after the other. So we thought we organized this seminar series to highlight some of them, to remind the wider audience of those new and additional features. And we hope that sort of you all can learn something. I will definitely learn something because even I have trouble to catch up with all the greatest and latest feature of Galaxy. So at this point, my first thank goes to Elixir and in particular to David, who are responsible for all the logistics behind this seminar. And then my second thank goes to all the speakers, in particular today's speakers, Marius van den Beek and Aysam Gerler. But before I hand over to them, I just want to highlight some 2 other new things in the world of Galaxy. So if I can have the next slide. So we recently added 2 movies, kind of Galaxy commercials, one about how to become part of the Galaxy community, and another one sort of explaining the Galaxy training network, so this extra part of the Galaxy where we offer a lot of training possibilities. So I highly recommend, if you want to kind of get a little bit more background on Galaxy, on the Galaxy training environment, have a look at those 2 videos in addition. So, but maybe switch to the next slide, yes. So it's my great pleasure to hand over to Marius and Aysam. Both Marius and Aysam have been part of the Galaxy core team for quite some time, several years, and they will talk about latest and greatest features in workflows.
Yes, thank you very much for the introduction, Hans-Rudolf. Thanks, Elixir, for providing us this opportunity. So as we've heard, today is all about workflows in Galaxy, and we can divide this into sort of 7 different parts. And I hope that you'll feel inspired to go out and try all these things that we're going to talk about and that we're going to show you. This is going to involve a live demo of the things that we're talking about, because oftentimes just seeing how you can do it is so much more useful than an abstract description. And so we're basically starting from how you can go from an ad hoc analysis, which is something that Galaxy is great at, to something a little bit more formal and more amenable to verification, to sharing, to communicating, and to providing as methods, which is turning that analysis into a workflow. Then we'll look at the Galaxy workflow editor and its features. And we're not just going to talk about the new things, but we're trying to give you a global overview of all things you can do, why you may want to do them, and how you can do that. Then we're going to talk about workflow invocations or workflow runs or workflow executions, however you want to call them. Then Sam's going to take over and talk about a really cool new feature that are automatic workflow reports. Then we're going to briefly circle back, and again, Sam's talking about best practices and how you can make sure that your workflows are great, that they are descriptive, that they are understandable, And then I'm going to show you a few tips and tricks, things that sometimes come up and that might be a little frustrating if you're just getting started. And then I'm going to talk about how you can share, publish, and find these workflows. All right. So yeah, Galaxy is a great platform for exploratory analysis. So you have your data, and maybe this is new data, maybe you haven't worked with that before. And what that involves is always, you have to try some things, right? So you start with your data, you don't quite know yet where exactly you're going, or maybe you know where you want to end up, but you don't quite know yet how to get there. So it's very easy to fire up a tool in Galaxy and see if it produces roughly the right, the thing that you're interested in. And if it does, maybe you need to change some parameters. And so you do that, and then you do that again and again, you rinse and repeat. And at the end, well, you're good, you're happy. And of course, Galaxy is not the only environment where you can do exploratory analysis. Notebooks are widely used for that sort of thing. And we're going to hear more about notebooks in Galaxy in one of the next seminars in this series. But there's also one thing that is very easy and kind of dangerous to do in exploratory analysis. It's very easy to make mistakes. You may select the wrong sample, or you may have chosen a parameter that doesn't actually do what you think it does. Or maybe you run the analysis again and you have a different result. So these are some dangers of exploratory analysis. And so an important thing, something that I learned early on when I did my PhD, is that you need to verify your analysis. And so this is where things are great in Galaxy, because whatever you do, we record every parameter that you've used to execute a tool. We record every input, every output. So given an output, you can see how it has been produced. So this is very important aspect in reproducibility. And so just to highlight this, this is the result of doing an exploratory analysis, where you end up with this series of data sets. And because we record all these parameters, we can go back and actually construct a workflow from your ad hoc analysis. And importantly, if you drill down into the workflow, you can see all the parameters that have been set. And another thing that is great in Galaxy, and that is a bit more complicated, we have to take a little bit of extra measures in notebooks, is that the analysis history is linear. Everything that appears at the top of your history is newer than what was before. So there's no chance that you're changing the input data set. And then you will never be able to redo the steps to get to your output data set. So these are some theoretical concerns. And in practice, you can extract the workflow and then redo it and verify, did you really using the same input, same parameters? Are you getting the same results? And then you can go to other data that you can use as a control, because it does happen if you have some experience in data analysis. It does happen. You take your beautiful method that works great on your data and you use it on another data set, and now you're getting different results. And now, is that because maybe you've done the analysis differently without really noticing it? Or is that because the data is really different? So workflows really help with that problem. It makes it very easy to repeat the analysis. And then, of course, you can try it on additional data, right? So I want to start the sort of show and tell by going to that actual analysis. So here we have two data sets. One contains normalized counts. So what this is not all that important, but basically you're starting with tabular data and some normalized counts. So this is an RNA-seq experiment. So this is an output you could, for example, get from dseq2, which can output normalized counts. And at the same time, maybe you're more, if you've ever used dseq2, but it's not important for this talk, but if you've ever used it, you might be more familiar with this, where you have the log4 change, average expression, p-value, adjusted p-value. So this is the input, and now we want to, and they're not in the same order. So now you want to bring them all in the same order, and then see maybe just for the top differentially expressed genes, how they cluster on a heat map. Okay, so what we can say is we can filter. So this is the filtering tool in Galaxy, where you can say the value that is in column 8 should be below 0.01. So column 8 here is the adjusted p-value. And then you can do a similar filter on the log4 change that on average should be above 4. And then you can sort. And now say you want to get just the first 20 genes, because otherwise your heat map's getting too big, and anyway, you're just interested in the most significant events. So then you can just say, select the first 21. So that's one header line, and the rest is the data. And then you need to join that back to the normalized count. So we've started this out with working on the differentially expressed data set, but now we want to get the normalized counts back so that we can use the normalized counts for the heat map. So that you can do by joining two data sets. So joining the first data set and the one we just produced. And then you just cut out the columns that you're interested in. So this is the gene symbol, the sample, and the relative expression string. And then you can create a heat map, and this looks beautiful. So I mentioned before, like the analysis here is chosen at random because it's small and we can easily talk through it. Of course, a real analysis might involve many more steps, might start directly from the raw sequencing files, but it doesn't matter. So now you've reached the point where you say, okay, this is good. I can work with this. So you can go to the history menu and you can say extract workflow. So as I mentioned, we record all the parameters, so it's easy to create a workflow from this, because a workflow is just a series of steps put together with parameters. So let's start from that. So this menu allows you to give the workflow a name. So let's call that plot heat map. And then here you can say, okay, these two are the input data sets, because no job ran on it in this history. We make this assumption that these are just the input data sets. And then you can select which data sets you want to include. In this case, we want to include everything, but maybe you have some failed attempts in there, so you can just exclude those failed attempts. So then if you click here, create workflow, you're ready. You can now run the workflow. This is as simple as it gets. All you need to do now is select the normalized counts, and you need to select the differential expression results for the first one. And you click here on run workflow. And if you've done this for the first time, congratulations, you've just executed your first workflow. And we can just make sure that the result is really the same. So I should mention I am running this currently on my own machine, because Use Galaxy is going to be down exactly during the webinar for 2 hours. But otherwise, you can do this on any Galaxy server. Yeah. So let's wait a few seconds for this to finish. Oh, and we can see the inputs here. Oops, I selected the wrong input. So even with workflows, things can go wrong. Okay, this is another way to run the workflow. So it's the same workflow. So let's do that again, but this time we're going to select the right input. So this is really just to verify that this is going to work. Yeah, so here we also see that this is the invocation. So I already talked about this before. Invocations are what the actual execution of the workflow. So a workflow may have many invocations, so many runs of this workflow. And we can see the inputs that were chosen, and we can see the steps here. The steps also have the details, so you can check which output data sets are produced. You can expand the job, and you can see the parameters and the inputs that we used. So this has the full details, everything you need to know about that job. Okay. So there we go. We have our heat map, and we can use the Scratchbook to see whether our workflow produced the same result as what we had during our exploratory analysis. And so this is how it should look like. These are exactly the same. So that's great. Okay, but of course, this is not where it ends. We're talking about advanced workflow features. So in Galaxy, you have these different modes here, and on the top, you can select workflow, and this brings you to a list of workflows. So I have quite a number of workflows here. For better organization, you can tag your workflows and then order them. So when you click on the name of a workflow, you have a couple of different options. You can copy it. So you can copy the workflow and then rename it, change it. You can download it. You can share workflow. You can preview a workflow. So if we just, oops. The wrong point. All right. So if we click on edit, this loads up the workflow editor. So you may have seen this left part before. So this is the tool panel. This has the different tools that you can use in a workflow, but these are not the tools of the workflow. On the right side, you have sort of the control panel, and in the middle is a view of the workflow. So this workflow has a number of steps. They're a little bit bigger than what you can see on my screen. So you can control the zoom level here. You can change these boxes around. And if you have sufficiently messed up the boxes here, and you're absolutely not happy with how things are looking like, you can go into this workflow options menu, and you can select auto layout, which tries to find a reasonable representation in space for the different workflow boxes. So then these are the individual parts of a workflow. So we call them steps. We have different step types. So these step types are represented by the small symbol here. So this is a input data set. Then you have tool tool steps. So these have this little wrench icon. And that's all the steps we have so far. So it starts with the filter tool and ends with heat map tool. Okay, so that's okay. We started out with just the history, but we may want to provide a little bit more information. Like, okay, what does this workflow do? What are the individual steps doing? What input data sets can be used? So by default, when you start this workflow, it accepts everything that the connected tools accept. So we have some tools that can only work on BAM data sets or FastQ or mass spec files. So in this case, it's not that useful, but you could say that you only want tabular files. And so it actually disconnects the downstream steps if the inputs are not compatible. So if I say this is now FastQ, then it says, well, that's not possible. So this is an important feature of the workflow editor. If something doesn't work, things turn orange, and you can see that it says that the output data type FastQ does not match the input data type tabular, which makes sense. So if you see this, This is very helpful. So we need to change this back either to nothing or to tabular. So let's say tabular, because this helps whoever wants to run the workflow, as well as Galaxy, to understand that only tabular input works here. And so we can add the annotation here. So we can say results of differential expression analysis. We can say that, and when we click on run, you see this little annotation here. So this helps whoever wants to execute the workflow to understand what data set is the right data set here. So then I've explained input data sets. These are tool steps. Tool steps, of course, have parameters as well. So these are the parameters that we've chosen initially during the analysis. So these are producing intermediate outputs. So we've seen that in our history. There's a data set called filter, filter on dataset 1, filter on dataset 2, sort on dataset 4. So this is not very helpful. And these intermediate datasets are, once we are sure that they do what we want them to do, they're not interesting. So there's this box here that lets you hide outputs. So we can do that. So this means the datasets are still going to be produced, but they're going to be hidden in the history. And maybe we want to highlight also what are the important outputs of a workflow. So in this case, I would say only the heat map is what we are interested in. So you can go to the tool step, and then here on the right side, you can scroll to configure output. And then you can say, this is the heat map. And so this becomes then a workflow output. So if we save this and we run this, you will see that the intermediate data sets are not going to be produced. So let's select the right inputs. So now if I click on run workflow, we see these data sets are queuing up. But you see that once the execution is done, they become hidden here. So if you're confused about this and you want to see the intermediate things without, you can always go click here and find all your hidden datasets. But if you've used Galaxy with a lot of datasets, you know that this can be thousands and 10,000s of datasets. So this is very handy if you hide all the datasets you're not interested in. You can still conveniently find them back here in the workflow invocation if necessary, but they don't clutter your history. So your history also loads much faster. It's easier to understand what is going on. And as you remember, we've just configured a workflow output. And so this output is then here. So you can also see the data sets directly from within the workflow invocation output. And these workflow invocations, they are in the user menu. So if you go in the user menu, workflow invocations, you see all the workflows that have recently run. Yeah. Okay. So these are some of the important features. So we've seen the nodes, the data inputs, collection inputs. Another important feature is input parameters. So you can think of workflows as sort of programs that you've assembled from individual building blocks. So these are the tools. And if you've ever written a program, what you do is you specify, you can change this parameter. So you can say, for instance, my p-value should be 0.05, or should it be 0.01, or should it be 0.01 to be significant, to be considered significant. And while you can just say, well, user, you just open the workflow and you change that parameter, it's much friendlier and better practice to say, this is a parameter, you can change it. And you can also provide a default value. So one thing that we can change is, for instance, how many genes are going to be included in the heat map. So this is determined here by this parameter. And so to make it a workflow parameter, what we're going to do is click here on the Add Connection to Module button. I hope that's big enough. So this is this one here. So when you do that, there is an input here appearing in this tool step. And of course, we try to make this as easy as possible to use. It looks sort of like a dataset input, but when you try to connect it, you see that doesn't work. Because this needs to be connected to an input, to a workflow parameter. So the workflow parameters, they are here in the input menu. I should also mention there are 3 input types you can choose here. You can choose datasets, dataset collections, and simple inputs used for workflow logic. So these are the workflow parameters. We're going to show the dataset collections later. But okay, so let's get a integer parameter. So we can start out by saying, oops, where is this one here? So we can connect this one because it is an integer parameter. So if we hover over here, now it's green, and that means we can connect it. So you have the option here. So you can say how many genes to plot. And then you can say this determines how many items will appear in the heat map. And we can say, decide whether this parameter is optional or not. If it is optional, we can decide to specify a default value or not. So in this case, we could say, let's put the default value of 21 that we had before. We could save this, execute it again. So now we have this input parameter appearing here with this nice little help text that we just wrote. And we can change this. So now we could say, let's say 31. So now we should see 10 more items appear, 10 more genes appear in the heat map. And the input has been recorded here. So this is important if you want to run the same workflow again, or you see a workflow execution and you want to know, what did I actually do here? So this really brings out what is important, what have I changed? Okay, so we can look at the steps. So this parameter went into the select first parameter. And so in the jobs, we should see that there were 31 lines set. I mean, the value is 31 for the select first parameter. So that worked. We got 31 here. So we changed it from the default. That was 21. And this looks different. So that makes sense. All right. Okay, so now you've got a workflow that is pretty cool, but what it is still missing is sort of what is the license? So if you want to share this, you need to say, what is the license? Who created the workflow? And you can add some colorful tags in order for people to find it in their list of workflows. So one commonly used license, MIT license. This is a fairly free license, meaning people can really use it for whatever they want to use it for. And let's say we add a person. So let's say, yeah, I would just add myself, and I could say, I could give a URL. So this might be my, I don't know, my social media profile, or the URL of my department. I could also add my ORCID identifier, which I never know which one it is. So, and here I could add a URL, I could save this here. And I might add a tag such as RNA, seq, heat map. All right. Okay. So if you maintain these workflows over time, you may want to use different versions of a tool. So let's say the year is 2016. You've used BWA MEM, and now you come back, it's 2021. Your workflow is still going to work, but that tool may have improved significantly over time. So if you select any tool, there is this little button here. So I will just increase this again. So with this little button here, you can select a different tool version. And so that way you can go to the latest version of a tool, then you can switch it and execute it with another version of the tool. Okay. Okay, another thing that you can use are tags. So tags are, dataset tags are used to identify a sample or to describe something about the sample. And these tags are sticky, meaning they will stick during your analysis. So to demonstrate this, we can say, at the first step here, we want to add a tag to the output of this file. So what we can do here is we add a tag. So we say name filter. And we're going to make some of these outputs visible again. So we see that this has an effect. So we can run this again. So you see the tags appearing, disappearing. So that's a bit unfortunate, but here they are. Okay, so that's fine. All right. So another thing is that you can select versions of a workflow. So we've seen here that the workflow was red. So the invocation failed to schedule. So we want to avoid this. We know that the previous version worked fine. So we can go back to a previous version. So this should now not have the tags. So if we go to configure output, oops. So this is the right version. Save it. Ah, is this maybe not the right version? Okay, so that's fine. This is the version that didn't add tags. Okay, so this is how you can change to a previous version. So if you made a mistake, you can always go back. So, all right, and then one last thing is that Galaxy also, in addition to tools, also supports workflows as steps. So we can create a sub-workflow now. So these are called sub-workflows if you include a workflow in another step. So we can create a new workflow, a new empty workflow. Okay, so if you start with an empty workflow, you need to include inputs. So here we're going to say a simple input. Actually, we need two inputs, one for the DE, one for the DE results, and one for the normalized counts. And then the trick to include workflows is you need to scroll here to the end of this section. And here is where your workflows are. And so this is the workflow. They're ordered by time of update. So this is the last one we just changed. And so this has the DE results as input. So we can connect that here, just like we do for tools. We have the normalized counts. You can connect here. And then we need to provide an integer parameter with how many genes to plot. So you add the integer parameter here. When you change this to integer, you say optional. And you can specify default values. So let's say 51 or let's say 16. All right, so then we can connect this, save it, and then run it. So this will run this step. So this is incredibly useful if you have, for instance, a common part of a workflow, for instance, quality control, and then you have another part of a workflow that is mapping and another part that is plotting. So we can execute this now. Okay. So now when we look at the steps of this workflow, there's only 4 steps. So 2 dataset input steps, a parameter input step, and another step. And this step is the workflow, so it has more steps. Okay. So this is the workflow in a workflow, and you can go even deeper. You can have workflows in a workflow in a workflow. That's fine. That's not a problem. Yeah. And so there we go. These are sub workflows. All right. Okay, so we've seen the workflow invocations already. And with that, I'm going to hand over to Sam. Sam, are you there?
Yeah, I'm here. Thank you.
Okay, so I'll stop sharing.
All right, let me share my screen. Okay, so thank you, Marius, for this detailed overview of these features. I will continue now to talk about 2 additional features we recently introduced, which add to it. And start from with the best practice overview, which we introduced. It's a new panel in the workflow editor. And let's start from a toy example from scratch to see how it works. If we create a workflow, for example, and just call it webinar test workflow and create it. And we introduce, let's say, just one simple tool, like the add column tool here. Then we can have already pretty much a workflow with just one tool. We could technically run it, but we introduced a feature to make sure that the workflows adhere to a certain quality, that certain errors are detected, that certain attributes, labels are set. And this feature is here in the workflow options overview. It's in the best practice. If you click on it, you'll see that this workflow with just one step has several issues, which are here indicated by this warning symbol. For example, this workflow is not annotated. This workflow also does not specify creator details or doesn't have a license. Let's say we want to fix this and we add a description here, description for this workflow, keep it as neutral, and then we come back and verify this. So this helps us to improve the quality of our workflow. In the future, we will also add more attributes here to be detected. I will continue, for example, the create details, which Marius already mentioned, creator details, so we can add a person here, say a test user, just save it, and we can continue through this list and lint all these problems away for our workflow step by step. Let's add a license. This is particularly useful if we share workflows, if we want to test them, have these kind of standards for our best practice. And this best practice also evaluates the inputs, how they are connected, if they exist, or if they are labeled. For example, here we have this input here, this two data set input is not explicitly specified. This is a warning here. Technically, you could run it, but it's not according to our best standards, and it's easier and better to explicitly specify an input data set and connect it. This makes the usage of this much clearer. And if we continue here, we can see there is another complaint here that this new input data set misses labels and annotations. So you can see if you click on it, it will highlight it and bring it to your attention. We can add a label here. Let's say this is our workflow input, and this is our main data source for this workflow, for this example here. Now let's continue and see, okay, we have another issue that this output file here is not labeled specifically. And again, we can click on it and label this, go to the output here and label it and say it's a workflow output. So by doing all these things, we can make sure before we share workflows, or if we want to continue including them in sub workflows particularly, that we adhere to certain standards, which can be very helpful because it's often in large workflows, it's not easy to see what has been missed or which outputs are produced and are not labeled properly. And this is also particularly useful when we look at new feature. We also recently introduced the reports. So reports are markdown documents which can be edited. It's markdown, so it has all the markdown elements, common ones available here. And it starts off with an example, but I will remove it here and add something new. For example, here on the left panel, we have objects we can insert now into our markdown. I could, for example, say I want to embed a data set. By clicking on it, I'll see already that since I properly labeled my my output in the workflow editor, it gives me already this suggestion here. It says this is a workflow output. Currently, I only have one. If I say continue, it produces the Galaxy specific markdown for this to embed this element into our report. So we can collect all the results and automatically produce a document containing these elements. Let me continue this by adding, for example, a figure. We have several visualizations here. I will just take the bar diagram, and again, let's operate on this one output. So when I do this, I get the options for this visualization. In this form here, I can change the label, I can change the value type, and so on. I can decide if I want to have a legend in my figure or not. I can pick colors, and particularly I can select the data columns I want to display. So let's say, just for this example, I want to display column 3 and column 4. And if I continue, again, the markdown is created for this object here. So now I can save this and run this workflow. Let's just take some more or less random data at this point, but for the purpose of this, demonstrating these features is still useful. So if I execute this workflow, what I will obtain is a report here. If I click on the report, I get the visualization of the data I have selected and this embedded figure. Of course, there are many, many more elements one can add to this. Collections, lists, certain attributes, job outputs, and so on, whatever someone desires to have in this automated report. So every time we run a workflow and have a consistent report coming out of it, we can execute this workflow, of course, on many, many different data sets and always get a consistent output for it. PDF-like document, in fact. Including text and so on, everything what is enabled by Markdown. We can also go ahead and further customize individual visualizations here by clicking on this arrow button. For example, if you decide to change the label later, the x-axis label, or if you want to add new data sets, you can do that too, new columns, and then you can save this as an individual visualization. So in another case, it might be useful to take this workflow produced report and further add data from other sources to it. And for that, you can click on this Edit Markdown button here. And what this will do is it will display first your content, which is, as I said, just Markdown text. And it will enable you to convert your invocation report into a regular page. So if I do this here, I obtain a regular page, Galaxy page, which I can share, which I can view. Oh, pardon, that's the wrong one. This one here, this is a new one, which I can view just regularly. I can edit the content and share it just like a regular page. Now let's view this. Okay, it's the same page. I can now go to the edit option here, and if I decide to add additional data from my history, for example, which I will do here, I will just add a PDB element by using this NGL viewer, and into my report again I get several options, which I will leave by default to default settings, and then the Markdown is inserted again. And if I view this, it adds these elements to my page. So, and then I can, of course, as I said, share this page and use reports to communicate the results of my workflow. Yeah. So with that, let me hand back over to the tips and tricks section.
Yep. Thank you. That's a really cool feature. All right, so there's a couple of tips and tricks. So one is if you have a workflow and you want to use data set collection. So we're going to hear much more about data set collections during the next seminar. So for now, I'm just going to say they are there so that you don't have to care about the sample identifier. The sample identifier for a data set is always kept during the entire analysis. And this enables us to scale Galaxy on thousands, 10,000s, 100,000s of data sets. So we can go back to the workflow we had just created. So I skip this one input dataset element. So normally how you would do this is you would say I add an input dataset collection, and you would disconnect this one, you would connect this one. But because this is now a very different input, Galaxy can't connect this because the output is already connected. And so there are some decisions that depend on this. So traditionally, what you would need to do is you would need to disconnect each output. And that is a little bit cumbersome. We may improve this in the future, but for this tips and tricks section, I want to show you how you can use sub-workflows to achieve the same effect. So we're going to leave this. We're not going to save the changes I just made. And we're going back to the sub-workflow we just created earlier. And so here we're going to disconnect the inputs. The integer input we could have kept, but okay. Yep. So then we're going to remove the dataset inputs and instead introduce the dataset collection. Label them. The label is really important. So now we can connect them here and we can connect them here. So one thing that you will immediately notice is we don't have this, this type of connector, what we call the noodle. Instead, you have this sort of ribbon connection. So that indicates that this is many data sets going into a step that takes in a single data set. So that's called mapping over. So for each element in a collection, the workflow gets run once. So we can save that now. Can go back to a history, and we create two collections that are just containing a single element. So we built a dataset collection, counts, and create a dataset collection for the DE. So then we can run our workflow on this dataset collection, E counts. So it only let us choose the correct datasets, so the correct collections here. And so this is the integer parameter. So I didn't add a label. You always need to add a label if you want to know what this parameter does. But let's say just 21. That's what we had used previously. So now our steps are being created. And so you see, this looks a little bit different. I mean, it's the same workflow we ran previously, but now it's in a collection. And if we look into that collection, we see it maintains the label. So if you look at the heat map output here, it's called heat map 2 on data 46, which, what is data 46? No one knows. But here within the collection, we get this. So that's one of the advantages of collections. I already mentioned that the workflow editor gives you this orange box and it tells you what exactly is wrong if you try to connect something that can't be connected. So one thing that was advertised a lot for this webinar is parameter sweeping. So I will just show you quickly how you can try different parameters. So this is a workflow that I have pre-built. It takes in a FASTA file, and it takes in a collection of data sets. Then it uses a special tool that is the pass parameter value that takes the data sets that are in here and turns them into text parameters. And this text parameter, you can connect to the reference genome parameter. So this is, normally you would select, so I can remove this connection. Normally what you would do here is you would select a reference genome. But if you want to try different reference genomes or different parameters in general with multiple different values, what you can do is you can make that a parameter connection. You can connect that here, save it, and run it. So we need a different history with these data sets. So let me switch here. This collection has one FASTA file and a collection that just has two data sets, one that says DiEM3, one that says DiEM4, that are the available parameters for this tool. So if we run this workflow, we select our FASTA file and we select the collection with the parameters. It will run the workflow, this workflow that uses MiniMap 2. And we'll create 2 jobs. So once the jobs are here. Okay, so now we've created 2 jobs. One is using the reference genome DM3, and the other is using the reference genome DM4. So that's a simple way to run a job that needs to be run with many different parameters. And given the time, I'm going to skip this one. I will just mention that there is also some tutorials on this in the Galaxy training material. We're always also trying to expand the number of tutorials on this, but I hope that was helpful. So one more thing I want to briefly mention is that we have recently started the Intergalactic Workflow Commission. If you're familiar with the Galaxy tools, you may know the Intergalactic Utility Commission that creates high quality tools. In the same way, we want to provide the infrastructure and the expertise that is needed to create really nice production-ready workflows that can be used by on any Galaxy server. So we really want to make sure that what is going to end up in the IWC are high-quality Galaxy workflows. We make sure that the workflows are tested and working, that they have proper versioning, that all the metadata is there, and really promote these workflows so that scientists will find these workflows. So we have the first set of workflows that are used for the SARS-CoV-2 work, but over the next weeks, we're going to add many more workflows. And of course, this is a community effort. So if you have workflows that you think are great and that you want to share with the world, please go to the IWC. I've included the link here. And you can create pull requests with the workflows. So this is, we just recently started it. So we'll include more documentation on the process. But I just want to mention that this is where you can deposit workflows. Workflows will be tested. We may have a discussion about whether it makes sense or not. Whether there's some parameters to improve or not. And then when they are merged, they will be uploaded to DocStore and Workflow Hub. So there is an organization called the Galaxy Intergalactic Workflow Commission. For now, we just have a single collection with SARS-CoV-2 workflows, but we envision that in the future we'll have RNA-seq, DNA-seq, ATAC-seq, ChIP-seq, metagenomics, all the different things that you can do with Galaxy. So if you have created such workflows, we're really interested in pushing them out there. And these workflows have proper versions, so you can select which version you want. And we're also going to work on Galaxy. So you can import them into Galaxy easily. And we're going to keep them updated and maintain them. Okay, so that's it. I would like to thank you for your attention. I want to say a very big thank you to the Galaxy community. Without the Galaxy community, we wouldn't be here. There's so much expertise and friendliness. And if you haven't joined yet, please join. I also want to thank people that have done a significant amount of work in the area of workflows. So John Chilton, Dan Baker, Wolfgang Meyer, Matthias Behrendt, Nicolas Lorenzo, and of course, James Taylor. So